So welcome back, Level 1 NCEA physicists and Earth space scientists. Today we're looking at another cycle from last lesson's the water cycle. Today we're looking at the carbon cycle and kind of comparing them. So the carbon cycle is nature's recycling system. So carbon, which is matter, moves through the Earth's four spheres. So for example, in the atmosphere it moves primarily as the gas carbon dioxide, which is the kind of the focus of global climate change. The biosphere, carbon moves through plants, through us, who are animals, for example, we're made of carbon, and other organic matter, like compost. In the hydrosphere, we have dissolved carbon dioxide, and also marine life use carbon in their shells, for example, and also at the bottom of the ocean you have large amounts of decomposing compounds which contain carbon. And we have the geosphere, so rocks are made of carbon, soil's made of carbon, and most importantly, I guess, in looking at human-induced climate change, fossil fuels. And examples of fossil fuels are oil and coal and natural gas. And carbon moves through the four spheres through a number of processes which are analogous to the processes in the water cycle. Okay, so we've got photosynthesis, so that's when plants absorb carbon dioxide to create sugars, and those sugars are then broken down into energy through the process of respiration, which is exactly the same process as we do as humans in our mitochondria. And then we have decomposition, so when you die, you basically return the carbon back into the atmosphere through decomposition from bacteria and fungi, and then fossil fuel formation and burning, so long-term carbon or long carbon chains are basically broken to release energy and also release carbon dioxide back into the atmosphere. Okay, because we're looking at the geosphere to begin with. So what's so important about carbon? So the importance of carbon is actually it's an electron configuration. Okay, so as you can see from the image there, it has 2 electrons in the inner shell, but also, more importantly, 4 outer electrons. Okay, so chemistry happens on the outer electrons. Why are 4 electrons important? Well, it means it can form up to 4 very strong bonds. And this means it can form a variety of different compounds. And it can, for example, form long-chain polymers like deoxyribose nucleic acid, which are found in all of our cells. And that's what we use to transfer information from our ancestors and also to our offspring. Then we have proteins as well, which make up our bodies, and also plastics, which don't make up our bodies, but we are, I guess, adding to them by eating microplastics, because they're very hard to break down. Then we have rings, which are used in things like sugars. Okay, so glucose and fructose found in your fruit, and also in medicines. Okay, so they're important for that as well. And then these hydrocarbons, which are the basis of fossil fuels, are long chains of carbon atoms, which then break to release energy. So how does carbon dioxide, which is the most common form of carbon, at least in the atmosphere, interact chemically? So in the atmosphere, it traps heat, contributing to climate change, so that's the greenhouse effect, which we'll explore later in a later lesson. In the ocean, it reacts with water to form carbonic acid, which is acidic, so ocean acidification. And also it can be absorbed, okay, as carbon dioxide. So that means oceans are very much carbon sinks. And in the geosphere, they form limestone, and also they form oil and coal, which are found underground so basically decomposing organisms which don't fully decompose under great pressure and temperature. They begin to form things like coal and oil, which are fossil fuels, which can be extracted and used and release carbon dioxide back into the atmosphere. So in terms of the human impact of the carbon cycle, which is a very important aspect of the internal assessment, so burning fossil fuels is one thing I'm going to focus on here. So for your cars, for example, releases carbon dioxide back into the atmosphere. Okay, so as soon as you break that carbon-carbon bonds and form carbon dioxide, that energy is being released, which is good, but it also releases carbon dioxide back into the atmosphere, which can cause that global warming. Deforestation, so cutting down trees, reduces carbon dioxide absorption, increasing the greenhouse gases in the atmosphere. Industrial farming, and we see an image there of industrial farming, Can also increase methane. So cows, for example, fart and belch a lot, which releases methane, which is another greenhouse gas. And methane also contains carbon, so its formula is CH4, so 1 carbon and 4 hydrogens. And in terms of the spheres, or the effect on the spheres, more carbon dioxide in the atmosphere, you get climate change, so temperatures start to increase globally. And because of this warmer temperature, you get more evaporation of water, which we saw in the water cycle lesson, and that leads to stronger storms in the atmosphere. And deforestation, well, again, is the biosphere, because plants are organisms. You get less rainfall due to less transpiration, so you can see that link now between the water cycle and the carbon cycle, and that leads to drier land, so more droughts. And finally, increased carbon dioxide in the atmosphere can then lead to ocean acidification in the hydrosphere, which isn't great, because that's going to affect the biosphere as well, because organisms don't really like living in low pH environments. So what does this all mean, and how can we help? So carbon's electron structure, those 4 outer shells, make it all possible. They form those strong, stable bonds, and 4 of them. They regulate the Earth's climate through the greenhouse gases, so carbon dioxide levels regulate the Earth's climate in terms of temperature. Fossil fuels, they store and release energy, and so that's also important, because sugar also releases energy for you when you have food, and it's broken down through respiration, so that's also critical. And what can you do to reduce the human impact? So using renewable energy, like the wind farms we see on the image. Plant more trees, so that increases the amount of carbon dioxide in the plants rather than the atmosphere. Reduce your carbon footprint, so rather than driving to work, I bike or I walk to work. And support clean energy initiatives such as carbon capture technology. But that's another conversation at a time, because that's kind of a trade-off on different things. But that's something you can research in your internal.